We have two forces acting on the same object. I've drawn a picture of these forces. We would like to find the direction angle and magnitude of F. F is the resultant force, in other words, the sum of the two forces acting on the object. Let's write F sub 1 and F sub 2 in component form. The magnitude of each vector is the force acting on the object. This is also the length of the vector in my picture. The magnitude of F sub 1 is 80 newtons, and of F sub 2 is 45 newtons. I've written the formula for writing a vector in component form in the rectangle. For F sub 1, we want to substitute 80 for the magnitude and 108 for theta. And for F sub 2, we want to substitute 45 for the magnitude and 244 degrees for theta. Using the component form of the vectors F sub 1 and F sub 2, we can now find the component form of F, our resultant vector. All we need to do is add the x components of F sub 1 and F sub 2 to find the x component of F, and then add the y components of F sub 1 and F sub 2 to find the y component of F. Let's take a moment to draw a picture of what's happening. F is F sub 1 plus F sub 2. So we want to move F sub 2 to where F sub 1 left off, connecting where F sub 1 started to where F sub 2 finished. We have a picture of F, the resultant vector. F is the actual pathway that the object will take when these two forces are acting on it. Drawing the picture will help me know if my calculations in the end are reasonable. Let me draw in the direction angle of F and the magnitude of F. Drawing the picture, I can see that my vector F is in quadrant 2. If you decide not to draw the picture, make sure you enter the x and y components in your calculator and at least make a sketch of F, because it's important that we know what quadrant our resultant vector is located in. In this particular one, F is located in quadrant 2. The formula that we're about to use to find the direction angle for F contains tangent, and in solving, we are going to need to use inverse tangent. Answers to inverse tangent in your calculator are only between negative 90 and positive 90 degrees, and so we might need to make an adjustment. Finding the direction angle, I'm going to use tangent of theta is equal to b over a, the y component over the x component. So let's put the y component in the numerator and the x component in the denominator. Solving, I inverse tangent both sides. Make sure you're in degree mode, and the calculator gives me theta is negative 38 degrees approximately. Looking at my picture, I can see that the direction angle is not negative 38 degrees. I chose this example to show you how important it is to know what quadrant your resultant vector F is in before you get too far into the problem. Since tangent repeats every pi, we're going to go ahead and add 180 degrees. When I do this, I get approximately 141 degrees. So our direction angle is approximately 141 degrees. The magnitude of a vector is the square root of the sum of the squares of the x and y component. So let's substitute in the x component of our vector and the y component of our vector And then using our calculator, I estimate that the magnitude is approximately 57 newtons.